Vitamin A and lung cancer, Group 1. The potential relationship between vitamin A and lung cancer has been a research topic since the 1970s. In 1975, Bierke published a study on dietary vitamin A in human lung cancer for the International Journal of Cancer. It was constructed around the study of over 8,000 Norwegian men that used mailed-in dietary questionnaires to assess dietary intake of vitamin A. Bierke observed that the rate of lung cancer among men whose calculated intake of vitamin A was above average was only 1/3 that of men with intakes below average. This led to more research into vitamin A and its supposed protective cancer benefits. Before we examine the studies conducted and the resulting impacts, let's first discuss each vitamin A and lung cancer a little bit more. Lung cancer is the leading cause of cancer deaths in the U.S. and claims more lives each year than colon, prostate, ovarian, and breast cancer combined. Although both first and secondhand smoke is the leading cause of lung cancer, non-smokers may also get the disease, which leads to the question of what other modifiable risk factors may exist for this disease. Vitamin A plays a central physiological role in the regulation of cell differentiation. Vitamin A is also known as retinol, which is only found in foods from animal sources. Green leafy vegetables, as well as yellow fruits and vegetables, do not contain retinol, but instead contain a series of carotenoid compounds. Of these compounds, beta-carotene is the most plentiful with potential vitamin A activity, as it can be metabolized by the body to form retinol. Carotenoids can further prevent singlet oxygen and free radicals in the body. Beta-carotene, unlike retinol or other carotenoids, is a potent free radical scavenger under certain conditions. The initial presumption that vitamin A had a direct association with lung cancer was rendered overwhelmingly null as further research was conducted. The apparent original connection of vitamin A with lung cancer may have largely been attributable to a misunderstanding of the relationship between vitamin A intake and serum retinol, retinol being the physiologically active form of vitamin A. According to Willett, and similar to findings about serum and dietary cholesterol, serum retinol levels have been found to be only minimally related to vitamin A intake. This distinction demonstrates a major possible weakness in earlier studies on the topic, as only vitamin A intake was observed. Vitamin A stems from a variety of sources, each carrying additional and varied micronutrients. Moreover, certain carotenoid compounds, when metabolized, can form retinol. These compounds bear other properties, such as serving as antioxidants, that may have contributed to the inverse association between their intake and lung cancer incidence. As such, the inverse association between carotenoid, rather than merely vitamin A intake, and lung cancer has been consistent in ensuing case control and cohort studies. Subsequent studies attempted to tease out the specifics to clarify any protective relationship, testing carotenoids and preformed vitamin A independently and examining the effect on lung cancer rates. One such study by Scheckow indicated that it was not vitamin A, but carotenoids that were to thank for fending off lung cancer. Taking a new approach, researchers turned to vitamin A biomarkers for new clues, but encountered complications arising from delayed sample testing and serum storage conditions. In addition, the results proved further frustrating in that the protective effects seen in earlier studies of vitamin A were not duplicated using blood serum samples, and collective results were essentially null. In the mid-80s and early 90s, a couple of nested case control studies looked at serum beta-carotene levels, with 6 studies essentially concluding that lower serum levels were associated with increased lung cancer rates. As researchers tied results from serum samples back to dietary intake studies, however, they noted that other factors could be at play, including other components of fruits and vegetables containing beta-carotene, or even possibly lifestyle factors common among participants consuming fruits and vegetables. Beyond that, cigarette smoking itself almost certainly was found to impact blood levels of beta-carotene and introduces significant confounding factors that are impossible to measure. The next step in unraveling the mystery of the relationship between vitamin A, beta-carotene, and lung cancer was to undertake randomized trials. 3 such trials were conducted in the 1990s, and the results were enlightening. During 2 of the 3 large long-term trials, intervention was halted due to an increase in lung cancer incidence accompanying beta-carotene supplementation. The 3rd study, while not as dramatic, indicated no marked impact on lung cancer rates after 12 years of supplementation. To add to the ongoing conversation around vitamin A and lung cancer incidence, vitamin D has emerged as a piece of the puzzle. In a study by Chain and Nehauser published in 2012, vitamin D was noted as having a protective effect on the development of lung cancer in participants, but that effect was significantly diminished in those with high blood levels of vitamin A or beta-carotene. It is believed that the connection between supplemental vitamins and increased rates of cancer is associated with antioxidants. Antioxidants are found in fruits and vegetables, as well as in vitamin A supplements. Antioxidants are said to prevent or delay cell damage. The idea is that one takes high doses of man-made oxidants, those which are in vitamin A supplements. It may cause an unnatural state in the immune system. This may cause an imbalance in the immune system, which may cause it to have a harder time killing harmful invaders. This is thus called the antioxidant paradox. At this point, it is clear that more research is needed, and we'll stay tuned to see how the relationship develops further.